Alex McColgan, and you're watching Astrum, and together we will find out everything that happened with the Rosetta Philae mission around Churyumov-Gerasimenko. As always, let's start right at the beginning. The Rosetta Philae mission launched on the 2nd of March 2004 on board ESA's own Ariane 5 rocket. It was initially set to be launched on the 12th of January 2003 and had a totally different target. But the Ariane 5 rocket had a major failure a few months previously with another mission, meaning all launches were grounded until they could determine and fix the problem. Once in space, the Rosetta spacecraft had an eventful 7-year journey on its way to the comet. As is often the case with missions to the outer solar system, it needed some gravity assist to get that far out. It had a flyby of Earth in 2005, and then a flyby of Mars in 2007. This Mars flyby was pretty risky. It would be just 250 kilometers above Mars's surface. Also, during this flyby, which lasted 15 minutes, it would be completely in Mars's shadow. And because the craft is solar powered, the craft had to go into standby mode, or its power levels would have been dangerously low, meaning it relied on batteries that weren't designed for this task to keep the craft powered in order to switch itself back on after the flyby. It also meant nothing could be transmitted back to Earth as this was happening. So mission controllers simply had to wait and hope the craft was able to turn itself back on. They called this the billion-euro gamble. But the flyby was a success, and the mission continued on, even managing to capture some photos of Mars in the process. The spacecraft flew by Earth a second time in 2007 at a distance of 5,700 kilometers. Interestingly, during this flyby, it was spotted and presumed to be a near-Earth asteroid, and was added to the Catalina Sky Survey as a 20-meter potential Earth impactor asteroid. It wasn't until a few days later that this mistake was found out. Heading back into the solar system with increased speed from the flyby, its trajectory took it past 2867 Steins, a small 5-kilometer asteroid in the asteroid belt beyond the orbit of Mars. Rosetta did one final Earth flyby in 2009, which finally gave it the boost it needed to reach the comet. During this last leg of the journey in 2010, it flew by another asteroid called 21 Lutetia, which is 100 kilometers in diameter. I think seeing both these asteroids gives an interesting comparison between asteroids and comets, because as you're about to see, they look remarkably different. After visiting Lutetia, the spacecraft went into hibernation mode until 2014, until it started to approach the 4.5-kilometer wide comet Churyumov-Gerasimenko. After a number of burns with the onboard thrusters, they aligned the trajectory of Rosetta with the trajectory of the comet. As Rosetta approached, these fantastic images started to come in, and they surprised everyone. The comet seemed to actually be a contact binary, full of jagged edges and sharp sides, cliffs, valleys, and crevices. It's a breathtaking sight to behold, and is really a lot more interesting looking than anyone had previously thought. But upon seeing these images, mission planners collectively thought, how are we going to land on this? You see, the Rosetta Philae mission has two parts: the orbiter, Rosetta, or the mothership of this mission, and a much smaller lander probe, Philae. Mission planners wanted Philae to land on the surface in order to closely examine the materials making up the comet with a variety of different scientific instruments. They couldn't afford to have it fall over on its back upon landing, not providing any scientific data about this special object. So the first thing Rosetta did upon entering orbit was to map the unusual surface of the comet to find the ideal landing site. Apart from the non-spherical nature of the comet, another thing to consider was the amount of outgassing at any particular site. You see, some parts of comets are very active, with lots of water being ejected into space, especially as the comet approaches the Sun. This water outgassing into space is what forms the defining characteristic of a comet, its unique coma. Landing on an outgassing site was seen as too dangerous for the health of the Philae lander, so a less active site was chosen. So, on the 12th of November 2014, Philae was ejected from the Rosetta mothership and started its descent towards this section of the comet. Philae was equipped with 2 harpoons, which were due to shoot into the surface to stop the probe bouncing on impact, as the escape velocity of the comet is only 1 meter per second. To give you some perspective, if you were standing on its surface, you could probably jump off it altogether. Its gravity too weak to pull you back. There was eager anticipation and nervousness at Mission Control as Philae descended, as due to all the many different factors, there was a lot that could go wrong. Philae eventually touched down on the surface, and as the spacecraft landed, it sent back a landing signal to Mission Control to say, "Job well done." What Mission Control didn't realize at that moment, though, was that their worst case scenario had just happened. The onboard harpoons hadn't fired, and although the probe had landed, it immediately bounced off the comet's surface. Commands were sent to it to start performing scientific experiments, but Philae was actually floating in space at that moment. There was a serious amount of confusion for a while until they realized that it hadn't properly come to a rest, and was still in the process of bouncing. Luckily, the bounce's velocity was only 38 centimeters a second, meaning that it only rose 1 kilometer from the surface before eventually coming back down again. Over the course of 2 hours, it bounced 3 times before eventually coming to a rest. Sadly though, it was well away from its initial landing site, and came to rest here, in a region that was often obscured from the sun, meaning it would quickly run out of power due to its solar panels not getting much light. On the other hand, it was extremely fortunate that it landed the right way up, so it could still collect at least some valuable scientific data. Mission controllers suddenly had a rush on their hands to collect as much scientific data as possible before the batteries ran out. Their estimated 5-month mission suddenly shortened to less than 60 hours. By the 14th of November, battery power had run out and communication was lost. But amazingly, in June of 2015, with increased exposure to the sun due to the comet's closer approach during its orbit, the little Philae lander was able to turn on again and sent a signal back to Rosetta. Although the signal was intermittent, the lander was able to perform one last science experiment, which was to drill into the surface of the comet, and it sent back its results. As time went on though, the comet became more active as it got closer to the sun. It originally only outgassed 500 grams of water and dust per second, but at this point it was outgassing 300 kilograms. In order to keep Rosetta safe, it had to orbit further and further out. By the 9th of July, Philae transmitted its last signal and then went quiet forever. It wasn't until September that mission controllers eventually found the resting place of Philae. You can see its legs sticking out just by here. Knowing where Philae landed was important, as it would put the scientific data it collected into perspective. So, what did Philae discover while on the surface? Did it put those 60 hours to good use? And what about Rosetta from orbit? Was it able to make some groundbreaking discoveries? Well, you'll have to wait for the next episode. And considering I'm saving the discoveries for another video, shows that they did uncover quite a bit.